So let's imagine that we have two objects, one of mass m1 and the other one of mass m2, and there's some distance between them, and of course they're attracted by the force of gravity. So we have a coordinate system. The origin is here, and so let's say that this one is at some position that we label R1, and this one is at a position labeled by position vector R2, and R2 minus R1 is equal to the vector between the two objects. Now, the force on this one is that way, so we can say F1, well, let's do MA equals F. Well, let's just write the force. The force is Gm1 m2 over R squared times R hat. Well, R hat is really R over R magnitude. This is equal to M1, right, MA times R double dot, the acceleration of this R vector. And the force on this one is minus, right, G M1 M2 over R squared R hat, and that's equal to M2 R double dot, the acceleration of the same object. So we can say that, well, we know that R is equal to R2 minus R1, so it's R2 minus R1, and this is, well, let's now take derivatives of this. So this R double dot is just two derivatives of that difference, and that's minus G M1 over R squared, R hat, minus G M2 over R squared, R hat. And again, let's, as we mentioned before, let's try to write the R hat in terms of R, because we want to develop an equation that tells us how this R vector is changing, how M1 is moving with respect to M2, the relative motion of these two objects. So we get minus G over R cubed times M1R plus M2R. And so we can write that the second derivative of R in T plus G, we'll pull out the R there, M1 plus M2 over, let's write it as R, well, we already wrote it here, so yes, it's R cubed times R. This must be equal to 0. And this is the equation of relative motion between these two objects. Solving it gives us R as a function of whatever variable. So if we have a function of time, we have a function of some other variable. So we solve for this quantity, R, and that'll tell us, well, if we have it as a function of time, it tells us how the relative, what the relative motion is of M1 with respect to M2.